chapter 13, all right, surface area and volume. So in exercise 13.1 we'll be asked to find the surface area of a cuboid. So let's go one after the other. So first is a cube, all right. If I ask you how many faces, right, does a cube has, you will say it has 6 faces. What are they? The top, the bottom, the left and the right and the front and the back. It has 6 faces, all right. So it's an example of a die here, right? The top is here, the bottom we can see, left is here, right we can see, and the front and the back. So if I dismantle this die, it will look something like this. You can see all the 6 faces here, right? So how do you find the surface area of a cube? You have to add the area of all the 6 faces. Once again, you have to add the area of all the 6 faces, all right. Now if you look at a cube, remember that all the sides are equal, all right, all the sides are equal. And also if I take out one face of a cube, it will be in the shape of a square. So remember this, all right. Now let's see how the formula comes. So if you look here, I've already written for us surface area of a cube is 6 times a square. So how does this come? Let's have a look at the example here, all right. So if I ask you to find the area of this one face, see, like I already told you, it is in the shape of a square, right? So it's like finding the area of this square of side A and A. So what will you get? If you'll get a square. So you can see here all the faces are in the shape of a square, so all the area will be a square, and a square. And like I told you, how do you find a surface area of a square? You have to add the area of all the 6 faces, right? You can see here, and that is how we're going to get 6 times a square. Now let's do it cuboid. So even a cuboid has 6 faces, right? Up, down, left, right, front and back. The difference between a cube and a cuboid is here all the sides are different. The length is different, the breadth is different, even the height is different. Clear? All right. And also remember, the top and the bottom here, the top and the bottom will have the same area, the left and the right will have the same area, and the front and the back will have the same area. And if I take out one face of a cuboid, the shape will be a rectangle. All right, cube was a square, right? But for a cuboid it is rectangle. Okay, so this is an example of a matchbox here. Now let's see how the formula comes. So if you see here, I've written surface area of a cuboid 2 times length breadth plus breadth height plus height length. Now let's look at the example here. Like I told you, each face of a cuboid is in the shape of a rectangle, right? So if I actually find the area of this rectangle, your formula will be simply height into length, and that is how you get the area here, right? So now if I dismantle this mesh box, it will look something like this, all right. So remember, the top and the bottom are same. You can see length into breadth, length into breadth. The left and right are same, breadth into height, breadth into height, and the front and the back are same. Okay, length into height, and then front is again length into height. All right, so I've written here for us. Okay, you can have a look afterwards. So how do you find a surface area of a cuboid? You have to add the area of all the 6 faces. So you can see here plus 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 plus, right? So length into height, there are 2, right? So it will become 2 times length into 2 times length into height. It's here, right? 2 times length into height. And then if you look at length into breadth, there are 2, 1 is here, 1 is here. So 2 times length into breadth, and then breadth into height, there are 2, right? So 2 times breadth into height. And once here you can see that I can take all these 2 common, then I'll get a formula here, 2 times length breadth plus breadth height plus height length. So that is how the formula comes, all right? You have to add the area of all the 6 faces. Now once you're doing you're done listening, you have to give me an example of each a cube and a cuboid in the comment section. All right, one example each of a cube and a cuboid.